This project is comprised of two parts, a recognition module and a control module. The first listens for an audio key, and then uses NRFs to tell the control module to alter the outlets on a relay-controlled power bar. To begin, let's talk about the audio recognition. There are many ways to do this. First, I tried the Easyvr 3 Arduino Shield, but due to some unforeseen issues, I couldn't get it working in time. Instead, this circuit detects different frequency ranges. This microphone feeds the chip, which is the MSG EQ7. It splits the audio signal into discrete frequency packets, with their amplitude being a value from 0 to 1023. By only considering the high frequencies, things such as claps can be detected. Once the first module is triggered, this NRF sends a signal to the control module. The module is a PCB with three main components. The first is the receiver NRF. This is a service mount version of the NRF24LL1. Nothing special. This tells the microcontroller, a service mount ATmega328P, to change its output. This is then sent to the power bar terminal, which changes the output accordingly. The challenge with this PCB, however, is sourcing power. As you may have noticed, there's a lot of extra components. This is because we are tapping into the power bar's PCB. This power bar actually has some internal logic to it, so I expected to find a 5V DC power somewhere, but of course there's none. Instead, there is 120V AC coming directly from the wall, as well as 100V DC. This DC is there because of this component right here. This is a bridge rectifier, which uses 4 internal diodes to convert from AC to DC. Since these output lines already have capacitors for smoothing, these are the wires that are coming into my PCB. To reduce the voltage from 100 to 5, a switching regulator is used. This uses a technique similar to PWM to reduce the output voltage. The chip depicted here is the LTC3638 buck converter. To smooth out its output, there is a 1 microfarad capacitor and a 220 microhenry inductor. This is the power for the entire board. Sadly, the pitch on the FFC converter used to program the SMT microcontroller was incorrectly chosen, so the PCB is not currently working. However, I learned a lot from this project, so I wouldn't consider it a failure at all. Thanks for watching.